Greetings everyone. Um, Today I'm making a video about uh, video game history, and I'm going to share you some fun RF engineering facts and things they used to do in past. I'm not doing this out of boredom, but I'm doing this to show you how you can relate video games and history and math and all of that in a fun, particular way. Um, we are gonna talk about the Nintendo NES, Nintendo Entertainment System, or Famicom, because in Japan they call that thing a Famicom, which is this. There are multiple variations. The American, European. This one, for example, is French, because it has a this RGB audio output, as you can see here. I don't have the cable, but I will buy it someday. But most of these NES consoles possess two connectors. One is for the video output, and one is the RF or the analog output. And you also have a connector for the audio output. Of course, you have the input one for the power. See, as you can see better. And here's a sketch. It's not a great one, but you can find what do these pieces represent, like start and restart, or start and reset. Mistake. Slot for those D-pads. Slot 1, slot 2. Where do you put your cartridges in? And yeah, it's a box. So once again, I'm going to whiten this out. There's a special method. I had a problem with finding the right chemical, the liquid, but I did manage to find it last year, but I missed the key component, which is the sun. And once we get better weather, I'll probably do that as my next project, to whiten this out, get a video cable. I don't have a power cable, but I can easily make that. And maybe I will get the multi-cart, so I don't have to buy individual game, especially from scalpers. It gets quite expensive. I think I have a D-pad somewhere in the workshop. So, 1983, that was the year when it was invented, released, but that was only mainly for the Japanese market. 1985 US, and they called it Entertainment System. Now, they did this because there was a video game crash, and they thought if they make a home console, it just simply wouldn't succeed, because now everything's gone. Economy when it comes to video games. If they named it like Nintendo's Gaming Entertainment System or Nintendo's Gaming Machine, Special Machine, whatever, people would think, oh, this is just yet another video game console company, and they simply wouldn't buy the console. But they actually went for Nintendo's Entertainment System. So it's not a video game console, it's an entertainment system. And it worked out. 60 million copies worldwide. Woohoo, great, especially for that time period. Of course, despite being it simple, because it was 8-bit, many games were on the machine. Zelda, Mario, Metroid, Mega Man, and many of these games right here have updates till now. Not necessarily to the NES version, but they have remakes, they have They have licensed emulators for the Switch 1 and the Switch 2 and so on. This console uses cartridges. Now, this was a debate whether they would use disc, a cartridge, even later with the N64, with the Nintendo 64, that is. And now some people may argue cartridges are superior, discs are superior, that is better, this is worse, but Nintendo always sticks to their proprietary items, and that's why they choose cartridges. But cartridges are indeed superior when it comes to collecting and saving data, as long as you take care of the dust and it's not being stored in a dumpster. It will probably survive. But if the cartridge has a battery inside, you will have to eventually replace it, or you will need to pay for electronics technician or someone who knows how to fix that. If you're not willing to do that by yourself, and keep in mind there are risks. So if you're not tech savvy, it's probably a good idea to check that out. My good friend and a colleague Alen did that certainly multiple times over and over again. I did some cartridge saving where you take isopropyl alcohol and you have to clean the contacts. And I actually managed to save a pretty rare game just by doing that. Okay, so how does this console work? Is by powering it with an adapter. Also, fun fact, I think the original adapter gives AC output, but you can also use DC adapter. I don't remember, let me see, maybe it says here. Is it 9.5 or let me see. So yeah, AC adapter only 9 volts of AC voltage, 50 hertz, 1.3 amps. Yes, and this is indeed the French version. I got this off eBay. I won the auction. It was actually scratched in a post, so because they had to check because of the taxes and everything. And it wasn't too expensive. It wasn't really that expensive, but they had to check what's this. It's a big box, and they just went over with a scalpel or a cutting knife for the boxes. And how do you complain? Who's to blame there? I don't know, but it doesn't really matter. It's still in a great shape, just needs some whitening process. And on the output, on the signal output, we have, like I said, the video output, which has yellow. In Bosnian we call it cinch, like a connector, yellow connector. Maybe I'll show you a cable. Yes. So the yellow one is for the video, the white one is for the left audio, and the red connector is for the right audio because it's stereo. Of course, NES is mono audio, but there are some mods which allow you to convert it into a stereo. I think it just basically doubles the mono audio output. But yellow is the video output, and we are mostly going to talk about that. And now the problem was, this console back in the day, it wasn't exactly the cheapest. I mean, most people and families could afford, but I think it was equivalent to PS5 in today's prices. I'm not really sure, but okay, we got this gaming console, and people want that because they wanted to play games from home. They didn't necessarily want to wait in line and wait for the traffic and so on and so on. And that was Nintendo's genius part, to make a home entertainment system. Of course, you can carry it around in a bag, plug it in, and yeah, it works. And I think that was an idea for the Game Boy later. Now, when it comes to signal, as I said, so you have the yellow connector for the video, and there's also a black one. It's called an RF. And to make it simple, it just converts that video signal to an aerial signal, or the same signal that you receive from that analog TV station where you were browsing to watch maybe sports or some weather analysis, whatever, whatnot. And usually, channel 3 or 4, I think, was reserved. Some countries had different standards. There's also a like picture television standard. We have the PAL, NTSC, and SECAM. SECAM was mostly used in France, I think was Egypt, Iraq, Russia, and those countries. PAL is the European one. I think the countries from ex-Yugoslavia like Bosnia, Serbia, Montenegro, Croatia use PAL, and NTSC was the American. I think the NTSC was first. It was definitely the first standard. Then came the PAL, then SECAM, or SECAM, then PAL, but NTSC was definitely the first one. And in order to summarize this, NTSC is the superior standard when it comes to refresh rate. So, because in the US they use 60 Hertz as a AC standard, and because it's also aligns with the beam gum for the CRTs, because they use CRTs back in the day, it refreshes the picture faster. PAL uses 50, so and there's an equation when you multiply the number of lines and the frequency and all of that. PAL has it has better picture quality, but the refresh rate is slower, slightly slower. But you will see, for example, for the real OG NES tournaments and somewhat similar games, maybe even Zelda, I'm not sure, or Mario, they all on the NTSC just because of the refresh rates. And the thing about the RF modulator inside was that it basically acts like a TV station. So this NES right here has a built-in TV radio station for both audio and video, all in one. And now you may be wondering, well, how does this box, this entertainment system, how doesn't it affect, for example, your PlayStation 1 or calculator or this power supply bencher, because of the FCC? And that's a law that basically says that any component that the company makes, that you make, or that you want to design, you want to create, cannot interfere with another one. Of course, we all own cell phones now, but they all have their frequency spectrum in which can they operate. And that's the thing also about the phones. Before, then, now, and that's a good law, because you don't want to make a phone call with someone and anyone could just tap in, eavesdrop, or send information, whether the connection is being made with a wire, a line, or aerial. So every communication device or every electronical piece has its own standard. Or I think for the FM radio it's for between 88.5 or something like 280 megahertz. Or CB radio is between da-da-da megahertz and da-da-da megahertz. So they made it clear that whatever comes out of this, the signal may only be so strong that in order to know what's going inside is to directly connect it to TV. Now, of course, TVs were quite expensive back in the day, and because it was during a transition, not every TV had video and audio inputs, and they wanted to make as much money as possible, and those converters also weren't quite cheap, or they didn't want people to be having trouble. They wanted to make it kid friendly, teenage friendly, adult friendly. So you just plug in your connectors, your controllers, put in a game, and you're done. And they had to make a circuit that was quite cheap and reliable, because in factories, this is made by this is being produced in a big number. We are talking thousands, 10,000s, millions. So every cent being saved here equals more to the company. And they did that quite successfully. It's actually a pretty good RF modulator. Um, they did it. They created a circuit. Once you open this up, I'll actually did just now, because I put screws over in the workshop. I maybe need to clean this, but here it is. This is the TV out RF part. Many people make money by replacing capacitors, cleaning this, and repairing all of this stuff. So, what kids did back in the day, or at least I hope somebody did, even though this was and still is illegal, they took those receiver amplifiers, which basically they didn't look like this. I'll teach you later what this is, but it was basically it was an electronic device, equipment, a gadget, connected to an antenna, maybe for a building or multiple houses, to amplify those big, aerial antennas on roofs. So those gadgets amplify the receiving signal from TV stations, and that signal was being brought to your home or apartment, multiple, houses, buildings, whatever, like some area. And what they did, because how do you turn, or how do you convert a receiver amplifier into a transmitter amplifier? By just flipping the circuit, by flipping the board around. They took this as an input, connected where the antenna or the input of the big antenna on the roof used to be placed, and on the output they actually connected the antenna. And if the antenna was directional, because there are many different sorry, they had many different types of antennas, because not every antenna transmits the signal in the same way. Some antennas are designed to transfer the signal equally, some are directional, and so on and so on. It's a quite an interesting topic. It does require a lot of math and physics and all that, but they did it by simply connecting it, and some of them even had splitters of those gadgets, those modulators. So they could connect in the same way. They could connect one part to your TV, so you could be playing, I don't know, Mario in your house, and at the same time, maybe like 50 feet or 50 meters or whatever away from you, your neighbor could be watching your stream of Mario, and not his boxing match or whatever he was watching on his TV back in the day. Or if a family was watching, I don't know, a cooking tutorial, and all of a sudden, boom, there's Mario. Or the pictures would go side by side. Oh, what's happening? Is my TV okay? And it probably did happen. And this is, of course, punished by law because, as I said, you cannot interfere with TV and radio stations, and you cannot interfere with basically anyone's equipment. That's jamming, it's illegal. Even up to this day, even though we don't use analog television. But you can actually search some subreddits and Facebook groups where they collect certain types of CRT TVs and make radio stations and RF fandom and hobbies. It's fun. I highly suggest you do that. But of course, this was only for these channels. Maybe that modulator was designed for every station, but they tweaked the frequencies, they messed around, and it's actually a good way to learn RF electronics and signals and systems and how does it all work. And yeah, as I said, um, of course the NES created that famous seal of quality type of sticker, which, yeah, this was licensed by Nintendo. This is good. Um, so yeah, as I said, PAL NTSC second video output. Um, I think that's basically all there is to it. I unfortunately don't have a video, but there's a really good video made by some American guy. He was doing experiments also in his basement, garage, whatever, whatnot. Uh, Good friend and colleague of mine also gave me this. This was probably used in a TV station as a prototype or to do some mixing and testing. You power it by using a DC adapter. You have an adapter for the video, so that the yellow one, and you also have for the white one, and you have some potentiometers here, or I think these are varicaps or variable inductors which change the overall parameters, and you can adjust the frequency and the level both for video and audio and stability. And once it's powered on, you can transmit your signal, and this is quite powerful too. Even without antenna, maybe like 2 or 3 meters away, I managed to make a Nintendo V TV station. So yeah, quite interesting. Of course, as I said, you may get to experience some issues when it comes to, what type of cable are you using, is it being the right power. There's also something called the impedance matching. Is the transmitters side part as good as the receivers, and so on and so on. But yeah, all over, like I said, this video would take way too much time to go into every single detail, but yeah, it's pretty interesting to discuss this with you, and it's interesting to think that this is actually a TV transmitter box in a way, despite being this old. 1985. Of course, for the Japanese Famicom version, you put video games like this, the vertical way. And it's quite smaller, and those D-pads had a voice function, so when you blow directly, I think you can scare some enemies in the game of Legend of Zelda. Not scare, directly kill. And yeah, that's basically it. If you have any questions or want to discuss this, I'll gladly appreciate it. Leave your opinions in the comments. Thank you.